A very good morning or good afternoon to one and all listening to this video. Today, I, Ishita Agarwal, a master's student at University of Toronto, is going to narrate a small lecture or tutorial on chemical reactions kinetics. I am a graduate student at University of Toronto and I'm studying chemical reaction engineering, and that's why I'll be taking a small tutorial on this particular topic. So, before any further ado, let's dive into our topic for today's discussion. And before starting, I would first like to let you know about our objective through this video and what would be the outcome or what can you expect to learn from this video. So, after this video, I hope you would be able to understand what is chemical reaction, what is kinetics, how is chemical reaction kinetics different from thermodynamics, what are the different factors that affect chemical reaction kinetics, and how do we calculate chemical reaction rates. So, let's start with that topic. So let's start with chemical reaction. And before starting that, let's just watch this very cool video or animation. We can say a lot of things going on in that beaker, right? So what is it? It is basically a chemical reaction. And chemical reaction take place around us on everyday basis. We have thousands of examples of chemical reaction taking place all around us. So can you give me some examples? Right. So I can enlist some of the examples for you. For example, when your car is running because of the energy which is produced by the gasoline that is burning inside the engine. Or when you are baking a cake, there's a chemical reaction taking place inside the flour, making your cake make that helps in baking of your cake and producing the final product. Or photosynthesis is an example of a chemical reaction by which plants produce their own food or energy from the sunlight. Right? So these are the some of very few examples of chemical reaction which are taking place all around us. So we understand that chemical reactions are very very important for us, and that's why chemical reaction kinetics is one of the major branches of of this particular physical study that helps us to understand more about these chemical reactions. Whenever we say about chemical reactions, they are often alternated with thermodynamics. Thermodynamics is a branch of physical sciences where we study about feasibility of any chemical reaction. By thermodynamics, we get to know whether any reaction is feasible or not. For example, according to thermodynamics, graphite can totally change into diamond over time because delta G of those that reaction is negative. That means that reaction is possible. But in real life, if I keep a graphite in front of you, do you think you would be able to see that change happening over some time, maybe 1 year or 2 year? Right? No, that does not happen because the reaction is very, very, very slow. Right? Similarly, when we say that carbohydrates can react with oxygen to produce CO2, right? But these carbohydrates can be sugars or flour or anything else, right? But do we really see that happening? If I keep a piece of sugar on your table, does it get combust? Do you see any combustion taking place? No, right? Because the reaction is very, very slow, and activation energy required for that reaction to take place is quite very high. In that last statement, I said two, three buzzwords. That is, that reaction is very slow, and the activation energy required for that reaction to take place is quite high. So, these all things are what we will try to understand when we study kinetics. So, kinetics tells us the rate at which any chemical reaction takes place or any chemical process takes place. And also, it tells about the mechanism through which that chemical reaction is taking place. That is, how exactly the reaction is occurring. We know that this reaction occurs, but how are the molecules aligned with each other to form product is what we are going to learn when we study about kinetics. So there are different factors that affect any reaction, any chemical change that is taking place. One is the concentration of the reactants. So all, as we all know, chemical reaction is basically a combination of different reactants or one reactant coming together and and changing into products, right? So basically, that concentration of reactant plays a very, very important role in determining the rate of reaction. So if you have higher concentration of reactant, you will have more likelihood of those reactant molecules colliding with each other to form the product. Similarly, if we have higher temperatures, we will have more reactant molecules having more kinetic energy. They will move faster and they will collide more often with greater energy and thus producing more product. And then third factor is catalyst, which is a substance which helps us to speed up the reaction. This can be by changing the mechanism or providing more surface area for reaction to take place. So catalyst can basically helps us to speed up the reaction. So if some process is going very, very, very slow, we can speed it up artificially or naturally using catalyst, right? So these are some of the factors that affect reaction, though these are not the only factors, but these are the most important factors that determine the rate of reactions. So what is that rate of reaction that I keep on saying again and again, right? So rate of reaction is basically helps us to determine change in concentration of reactant or product as a function of time. So, in this example, in jar A, you can see that mole A, we have molecules of mole A, which are basically denoted by red dots. What is happening in this reaction is basically mole A is being converted into mole B over time, right? So, in we can see at the start of the reaction, we only have mole A. Then these mole A, these compounds of A particle, they combine with each other to form B particle. And in 20 seconds, we can see that concentration of A has dropped to 0.54, while the concentration of B has increased by 0.46, right? And after 40 seconds, moles of A has decreased more, while the moles of B has increased. So basically, reaction rates help us to determine or monitor this change in concentration of reactant or product as a function of time. So in this example, we have butyl chloride, which is C4H9Cl, and we are reacting it with water to form butyl or hydroxide. And this table basically tells you the concentration of butyl chloride over time. So we can see at time is equal to 0, which is the start of the reaction, we have total molecules of butyl chloride as zero point 0.1. But at the end of the reaction, that is after 10,000 seconds, we see there is nothing, 0 moles or 0 molars of butyl chloride left in the reactant or reactant space, right? So basically, this we can plot this to understand how a reactant is changing over time, and we can see that the reactant is following this kind of curve. So this is how we determine the reaction rate. So for today's tutorial, I'll stop here, but I hope you were able to understand what is chemical reaction kinetics, what are the factors that affect the chemical reaction kinetics, and how chemical reaction kinetics is different from the chemical thermodynamics. I hope to see you again, and then we can continue the rest of the lecture. Thank you so much. Have a nice day.